well, when you see a fire, it's a very sickening feeling. And the last fire, I was on my way out the gate, and I heard the explosion and looked in my rearview mirror and saw the plant on fire. It's a terrible feeling.
I remember most about that. It was just so big. I mean, from miles away, I was driving to work after I got the page, and I said, well, that can't be us.
About 1 o'clock in the morning, we got a call that says, man the fire trucks, and we looked out and the flare was going, and I had to step around the flasher heaters, and when I did that, over at CFH, the heater was on fire.
When I looked out the window after the explosion and saw a fireball coming across the street that was as high as the windows in the control center, it really scared the heck out of me.
Had that explosion happened 10 minutes earlier, it would have blown my foreman up. He'd have never got out alive. And if it had been about 5 minutes later, it might have got me, because the valve itself, the pipe supports around this valve had melted to the ground.
The fire we had was, I guess, catastrophic. We had lots of damage.
Adrenaline pumping, scared, respect for the plant, the fire. Just a lot of emotions going through.
Very frustrating. I was embarrassed.
I was afraid.
It was a wake-up call.
Nervous.
I was scared.
Sickening. It's like getting kicked in the stomach.
We've got a lion in a cage out there, and we want to keep it there.
In February of 1999, I had been on the job less than 2 months, and I remember that I was, at the time, asleep in a hotel room because we hadn't moved into a house yet, and my pager went off. And I read it, and it told me that we had a fire in our HL unit. And it was a pretty disheartening event that I really hadn't gotten comfortable with my assignment yet, and we had a major fire in the process unit. We had suffered injuries, in some cases fatalities, and in many cases financial losses stemming from pressure equipment failures. As a result of that, pressure equipment integrity became a very important piece of the overall process safety initiative that the Alliance Refineries began on in 1999.
The purpose of the process safety initiatives is really to save lives, save injuries, stop leaks, stop releases, make the workplace a more comfortable place to work.
Human life is the most important thing. We can build another plant, we'll make more money, but we can't, if one person gets hurt or, God forbid, killed, then it's all for nothing.
If you can prevent the failures from ever happening and see them coming, I mean, you're going to increase that bottom line. I mean, that's going to make more money for the plant, more money for the company. And it's also going to help with our environment. You know, we're going to have less releases to the atmosphere. If we're keeping the stuff in the pipes, that's where we want it. We want it to be where we want it to be, not where it wants to go.
There's not one person in this plant whose shoulders are big enough to bear the burden of responsibility for the equipment. It is not an inspection issue. It is not a process engineering issue. It is not an operations issue. It is not a maintenance issue. It is not a management issue. It's an issue for all of us working together.
We've subtitled it, if you will, shared stewardship of assets, because at the heart of our process safety initiative for pressure equipment integrity is the need to get more people involved in protecting our equipment and preventing incidents, preventing releases.
I got a phone call at 4 o'clock in the morning, and on the other end of the line was an operator. And I'm going like, gee, this is the first time I've ever been called by an operator. That's kind of neat. What's going on?
We were starting the CFH up, and it requires us to heat the metal up to a certain temperature before we put high pressure on it. In doing this, one of the vessels we have to put a liquid seal in, and this would make the hot gas would go through there to heat the top of the vessel, but the liquid in the bottom of the vessel would keep the bottom from getting heated up. And I got to wondering, well, now wait a minute, does it just matter? We're only going to have gas in the top, and that's where the heat is. I couldn't really make it right in my mind. So it was either don't call him because it was too late at night or disturb him, which I figured all he could do is yell at me. So I called him up.
And I'm going like, wow, this is what we're after. This guy understands what we're doing.
And what we did is we looked at it operationally, made a change to the procedure temporarily to get this started, and subsequent to this, we've changed the procedure on a permanent basis.
I was a member of the inspection audit team at Martinez in '97, and then again I was on the inspection team in 2000. And it was very interesting. There was a big difference between the 2 years. We went there in '97 and we found a number of discrepancies, which we noted. We went back in 2000 and we expected to see that Martinez had corrected those. And in fact, they had corrected all of those discrepancies. But what was interesting was they had developed a new mindset. And the mindset was the inspection problems weren't simply the inspection department's problems. The entire refinery seemed to own those problems. The big thing that had changed was everybody was talking the same way and everybody was on the same program. It was clear they spent a lot of time getting together and deciding what are the big problems and what are the solutions.
The big change I see is a team concept, a working togetherness. It's not maintenance, operations. It used to be always borders lines drawn. PEI had a line drawn. You know, they're siloed in, and now it's almost like you all work in the same group. I mean, you're working for the same common cause.
I think we all have a responsibility for process safety. I think we all play a role, from my manager, who's responsible for getting us the resources that we need, to inspections, who works hand in hand with myself to make sure that there's a problem. They're the people that have the training to take care of it. Myself, I'm in every corner of the unit. If I discover something, it's up to me to let the people know, and I always make sure that I'm not the weak link in the chain.
My role in process safety is to ensure that I go home safe, my fellow operators go home safe, and the people working out there safe.
The cornerstone of the shared stewardship of asset work process is the OEMI team meetings that we're starting to have on a regular basis at our refinery. These meetings are very important to get cross-functional teams of people together to talk about issues and problems that we have out in the refinery in order for us to work together to solve these problems.
I don't think any one department or individual can adequately cover complex problems that are involved in a process unit. I think it takes all the disciplines.
It was a whole new process for me because I've been here over 20 years, and we were conditioned as operators to bring the unit down, isolate the problem, and bring the unit back up as fast as you could. Now you bring the unit down, you get it into what we call a safe mode. After it's in a safe mode, but then you sit down, you get all these people involved into these OEMI discussions, and you sit down there and you actually talk about the problem. And what it does is it brings up more problems than you actually see yourself. So by having the joint meetings, it may take a little longer to reach a decision, but I think you come to a better decision.
There's data that comes out that operators have that engineers don't have, and when you get OEMI, it's not just operations, maintenance, inspection, engineering. It's the right people that are involved with that aspect of the business to make the right decisions and be involved in the process. You need to include the right people that have the information that you need.
Previously, I believe some of our decisions were made based somewhat on emotion and somewhat on rank, who had the highest rank at the meeting. I believe that our decision-making process is going to be more fact-based and more inclusive. The people impacted by the decision are much more likely to be involved in that decision-making process.
OEMI teams with the diversity of experience and the right work processes give you outstanding results.
The value of CCDs is that it brings people together who are interested in pressure equipment integrity and brings that multidisciplined knowledge together to document the degradation variables. Anything that causes equipment to fail or leak is documented, and why it happens and what can cause it to happen. Everybody in the room learns from that exercise, and that document then becomes the foundation of knowledge for shared stewardship of assets.
The CCD helped us to pinpoint a major problem that we could have experienced with our high temp shift. There was a risk of high temp hydrogen attack, and we wouldn't have known this if we wouldn't have gone through the corrosion control document. And what we ended up finding is that we had no high temperature alarm to protect us, and the corrosion control document pointed us in that direction.
And it's not just pressure and temperature. It's pH, it's organic acids, it's chloride content, it's fluid velocity, it's the temperature of furnace tubes. There are a multitude of variables that are very important to be documented and controlled if we're to preserve our pressure equipment integrity.
This is a piece of 410 stainless steel liner from our heavy vacuum gas oil section, and it's an example of process creep. This was a problem that we recognized during the development of the CCD, so we paid special attention when we went into the tower to look for this type of attack.
I've been involved in 2 corrosion control documents, or CCDs, and the value for me is it highlighted the various corrosion mechanisms that could occur in various parts of the plant that I hadn't been aware of in the past. The knowledge transfer that occurs in going through a CCD and maintaining a CCD is a good mechanism to make sure that the knowledge stays on the unit.
Developing CCDs as a team gets us all on the same page. We all share each other's knowledge, and we understand where we're trying to go.
Management of change is a process in which things that are going to alter a process or alter the way that we do things, we try to have a document, explaining that change, making sure that all the interested parties, all the parties that need to know will get involved in it and also learn about this, so when the change does take effect, all affected parties are knowledgeable about it and we can just go on and carry about our business.
The management of change includes both hardware changes and process changes. I think we've been pretty good about capturing the mechanical changes, the hardware changes, the things that were physically different, but it wasn't always so easy to capture the process changes.
CCDs are what I believe is a very important tool in capturing all of our knowledge from the various disciplines that can then be referred to in a management of change.
Well, 10 years ago, MOC was hardly heard of. People would just make plant changes and they didn't have any way of tracking them or making sure that those changes were done properly. So now you have more reviews and more input to a plant change to make sure it's the right thing to do before it's done.
Yeah, in this shared stewardship thing that we're into now at our location, we've been working, one of the pillars has been working on how to make decisions, better informed decisions, and we've been using a risk assessment method.
You really can't run your business well unless you understand the risk you're taking when you do things or when you don't do things.
What you find is there's so many things to do in the refinery and so many things to work on, safety-wise, environmental-wise, or just reliability-wise, that you had to be some mechanism to put it into proper perspective as to priority. And by using risk-based, then you can start looking at all of them on the same playing field.
In the 11 years I've been here, in the beginning, my feeling is or was that a lot of the risk decisions were based on money. I'd say lately, after CFH fire and HP3 and different problems out here, my feeling is that a lot of the decisions are more based around process safety.
With the decision-making techniques that we're using, we get better decisions, they're more factual, and it diffuses emotions in the decision.
When making decisions, we must fully understand the consequences and the impact of those decisions.
You can go just so far by creating documents, creating CCDs, creating KPPLs, creating a risk assessment methodology.
Operator training is a big part of the implementation of our corrosion control documents, or CCDs, and we do that after we've finished developing the CCD with their help. We take it and we roll it out to all of the operating folks in the unit. We have several meetings scheduled so that all of the operators can attend. We go through the corrosion control document, how it's set up, how it's put together, why the different sections are where they are and how they all work together, and how it's available for them online on our computer system so that they could look up something if they have a question at any time during the night or day.
I feel that operators should know as much as possible about corrosion and material issues in their plant and what pertains to their unit processes.
But what I'd like to know as an operator, as a person out there, is why? Why not bring it over 1,000 degrees? What effect will it have on the piping, the materials inside there, the catalyst that does the reaction? Why is what I'm looking for.
Transferring the information to operations is very important because in general, when people are operating the units, they are not thinking about what could happen. They are thinking about optimizing. They're thinking about making it through a shift. And the corrosion control document can point them in the direction and say, hey, you know, this alarm is here because you could have high temperature hydrogen attack, or this alarm is here because you know, you may risk the integrity of this vessel. And not all operators are thinking, hey, I've got this alarm, this could end up being a safety incident. They're just trying to deal with it.
If we don't effectively transfer the knowledge that we're collecting in all aspects of this initiative to those key frontline players in operations and maintenance, the pressure equipment initiative won't succeed.
I think we'll know we're successful when, in the short term, we don't have any corrosion leaks. Corrosion leaks simply shouldn't happen. And in the long term, when we don't have any major incidents.
When everybody, all groups involved, embrace that they have a role in protecting the pressure equipment, and that we've made the knowledge transfer so that they can do that role.
When pressure equipment safety becomes second nature, like personnel safety has become over the last 20 years, we will really have arrived with shared stewardship of assets.
One of the things that I believe the Process Safety Initiative, and in particular the pressure equipment integrity portion of that, is going to bring to us is that we will have less surprises in the future. We will have less process safety events. We will have less leaks. We will have less unscheduled outages. So I'm expecting that our plants will run much better. I expect that we will have less environmental incidents. I expect to have less safety incidents. I expect us to have better reliability. I expect us to make more money as a business as a result of this activity.
My name is Theron Dufresne.
I'm Kirk Johnson.
I'm Darrell Robinson.
I'm Andy Chen. I'm in operations.
I'm a process engineer.
Process technician.
I'm in operation, and this is my refinery.
I'm Eddie Miller, and this is my refinery.
Hi, I'm Greg Jones. I'm an operator here at Motiva, and this is my refinery.
Hi, my name is Mike Mallett. This is my welding machine, and this is my refinery. Hi, I'm Richard DeCambra, and this is my QC lab. All right.
Let me do it again.
My name is Herbert Smith, and I'm an operator, and this is my refinery.
Hi, I'm Richard DeCambra, and this is, and I'm a...
I am Tyrone Smith. I am an operator, and this is my refinery.
My name is Chris Whittle. I'm a pressure equipment inspector. This is my refinery, and my job is to keep it out of the bayou.
Are we ready?
Yeah. You want to take 20 or take 21?
I'm Leslie Ward, and I'm an engineer, and this is my refinery.
I'm Harry Martin. I work in operations, and this is my refinery.
I'm Crystal Kane, and this is my refinery.
I'm Armin Abay, and this is our refinery.